On December 7, 2023, the U.S. Navy's newest Arleigh Burke class destroyer, the USS Thomas Hudner, arrived at its namesake's hometown of Fall River, Massachusetts, for a week-long visit. It was here to honor the late aviator and the city's most famous native son by bearing his name. But even more importantly, it brought with it an unveiling of one of the latest cutting-edge technologies fielded by the United States Navy, its new next-generation air defense weapon system. But before we get into what this advanced weapon system is, how it works, and why it's been billed as the future of air defense, let's take a quick look at the man whose name it now bears. Thomas Lewis Hudner, Jr. was a U.S. Navy pilot and aviator who was famous for his heroic actions during the Korean War while flying jet fighters against the North Koreans and Chinese. He was awarded the Medal of Honor, the highest possible award for valor in combat, for his actions after being shot down behind enemy lines. He successfully managed to get out of his damaged plane and land safely, despite having been hit by anti-aircraft fire from the ground crew. Then he attempted to save his fellow pilot whose ejection seat had malfunctioned and left him dangling from the wreckage. Despite the freezing cold temperatures, unable to help his comrade due to the damaged equipment, Hudson valiantly stayed with his fallen friend until he froze to death. When his own life was in danger, Hudson unhooked himself, donned his parachute, and floated back to safety. His bravery and selflessness in the face of certain death were cited as the reason he received the Medal of Honor from President Harry S. Truman in 1951. So now let's get into the weapon named in his honor. This new weapon system is known as the Next Generation Air Defense, or NGAD, system, and consists of several different components that work together to form a layered network of sensors, communications, and weapons. It uses advanced algorithms and artificial intelligence to analyze incoming threats and determine the best course of action. It then uses a variety of kinetic and directed energy weapons to intercept and destroy any airborne objects deemed hostile. The system's main sensor is a high-powered X and S band multifunction radar, which is the eyes and ears of the system. It can detect and track multiple targets at once from very far away. The radar also uses gallium nitride or GaN technology, which allows it to transmit more power and collect more information than traditional radars. This makes it more accurate and efficient and enables it to detect smaller, faster, and lower-flying targets that would typically be harder to spot. This information is then fed into a central command module, which uses advanced algorithms and artificial intelligence to determine the best way to engage and destroy any potential threats. This includes deciding which weapon to use and where to direct it. This helps ensure that every weapon used is effective and that friendly aircraft and personnel are kept safe. In addition to the radar, the NGAD system also uses other sensors such as infrared search and track or IRST sensors, which can detect the heat signature of aircraft and missiles. These sensors provide an additional layer of protection, especially against stealth aircraft that are designed to reduce their radar cross-section or RCS, making them harder to detect. They also have the ability to communicate directly with each other and with other air defense systems on the ground, allowing for a coordinated response if necessary. Once a threat has been identified, the system uses a variety of weapons to engage and destroy it. For example, the NGAD system can use the Rolling Airframe Missile, or RAM, which is a very short-range missile that's designed to intercept and destroy incoming missiles. It can also use the Standard Missile 6, or SM-6, which is a longer-range missile that can be used against aircraft and missiles. In addition to these kinetic weapons, the NGAD system can also use directed energy weapons such as high-energy lasers to intercept and destroy inbound threats. Directed energy weapons are relatively new technology, but they offer some advantages over traditional kinetic weapons. They're very fast, meaning that they can intercept threats very quickly. They're also very precise, meaning that they can engage small or lightly protected targets without damaging nearby structures or personnel. Plus, they don't have to be replaced after use like kinetic weapons do, so they can engage threats continuously for as long as needed. Another advantage of the NGAD system is its flexibility. The system's components can be deployed in a variety of ways depending on the needs of the mission. For example, the radar and command module can be mounted on a truck or other mobile platform so that they can be moved around easily. This allows the system to be set up in different locations and reconfigured quickly if necessary. The system can also be integrated with other air defense systems on the ground, allowing for a coordinated response to incoming threats. Now, while the NGAD system is still in development, it has already been tested and proven to be effective. In fact, it's been tested against a variety of threats including incoming missiles and aircraft. During the tests, the NGAD system was able to detect, track, and intercept all of the threats accurately and efficiently. This demonstrates the system's effectiveness and its potential to be a major asset in the defense of the United States and its allies. But before we move on, folks, I wanted to take a moment to ask you to consider supporting us. We're not funded by any outside investors or government agencies. We're completely independent, and so we rely on the support of our viewers like you to keep us going. If you think what we do here is valuable, then please consider becoming a monthly or yearly subscriber. You'll get access to a bunch of cool perks, including early access to videos, the ability to submit ideas for topics that we cover, and our private Discord server, so go check it out. Now, because the NGAD system is so advanced and sophisticated, it offers several advantages over previous air defense systems. First and foremost, its use of AI and advanced algorithms means that it can engage threats much faster than humans could. This is especially important against newer types of threats such as hypersonic missiles, which are designed to fly at very high speeds and maneuver in unpredictable ways. In addition to its speed and efficiency, the NGAD system is also highly accurate, which means that it can engage targets with greater precision, reducing the risk of collateral damage. Its use of kinetic and directed energy weapons also provides a greater range of options for engaging different types of threats. And its ability to communicate with other air defense systems and assets increases the overall effectiveness of air defense operations. However, there are also some challenges associated with the NGAD system. First, the system is very complex, which means that it requires highly trained personnel to operate it effectively. There are many different components and systems involved, and they all need to work together seamlessly to function properly. Second, the NGAD system is very expensive. As with any advanced technology, the cost can be prohibitive, especially for smaller or less wealthy militaries. Finally, there are some concerns about the use of AI in the NGAD system. While AI can make decisions much faster than humans can, there are concerns about the potential for errors or malfunctions. In addition, there are ethical concerns about the use of AI in lethal autonomous weapons systems. However, these concerns are still being debated, and there is no consensus on how to proceed. Overall, though, the NGAD system represents a significant advancement in air defense technology. Its speed, accuracy, and flexibility make it a powerful tool for defending against a wide range of threats. While there are some challenges associated with the system, the benefits of using it far outweigh the drawbacks. Now it's being fielded first on the latest Arleigh Burke class destroyers, Flight 2A, which are the most capable version of America's most prolific surface combatant. But it will likely be rolled out across the rest of the fleet as well as other platforms such as the Navy's new Constellation-class frigate. That'll give the United States Navy an unprecedented edge in terms of air defense capabilities, allowing them to protect themselves against even the most advanced aircraft and missile threats. And that just goes to show you how fast and how dramatically military technology continues to evolve. But what do you think? Is this a big deal? Do you think AI has a place in modern warfare? Let me know your thoughts down in the comments below. And of course, if you want to continue to learn more about the latest developments in military technology, then be sure to subscribe to our channel. We've got lots of great content coming your way. Thanks for watching.